This week's introduction for week 6, I'm going to give you an overview of NASA's rover Curiosity and its mission to Mars, as an example to help you understand what goes into a real mission to Mars. To give you an update, as of this month, Curiosity has been on Mars for 3 years. Feel free to check out this link for more details. I'm just briefly going to outline the main phases of the mission. These include preparing for the mission, so the landing site selection, assembly and testing, launching from Earth, voyage to Mars, approaching the Red Planet, entry, descent and landing, test drive on the surface, and surface operations. In preparing for the mission, the Mars Reconnaissance Orbiter had been sent to orbit Mars and collect data, i.e. take pictures using powerful cameras and spectrographic instruments, and helped assess potential landing sites in greater detail. In 2006, they began with more than 60 landing sites. Then, in September 2008, it was reduced to 7. In November 2008, it was reduced to 4, and in July 2011, reduced to 2, and finally Gale Crater was chosen. Now, the ideal landing site was to have clear evidence of a past or present habitable environment. The site was to have a favourable geological record, such as layers of rock that are preserved and exposed to the surface, making them accessible to exploration, as well as evidence of past water. The ideal landing site was also to have the elements essential to life as we know it, all located within a relatively smooth, safe landing area. Mobility, of course, was to be essential for reaching areas such as cliffs that may contain many layers of rock, telling the story of past environments on Mars. Now, assembly and testing of the Curiosity rover occurred at JPL in Pasadena, California. Then, they shipped the spacecraft to Cape Canaveral. This is where final assembly of the backshell-powered descent vehicle occurred. Curiosity was placed inside the backshell and closed off with the spacecraft's heat shield. The heat shield and the backshell form an aeroshell that encapsulates and protects the rover from the intense heat it was to experience during the final leg of the trip to Mars, and the friction-filled descent through the Martian atmosphere. The launch occurred with the Mars Science Laboratory and its car-sized rover Curiosity from Cape Canaveral Air Force Station on an Atlas V rocket. On the cruise to Mars, stability was maintained by spinning the spacecraft about its central axis at 2 revolutions per minute. Of course, they used the stars to navigate and 8 thrusters fired on command using hydrazine fuel in 2 titanium tanks. It took 253 days to reach Mars, which is only 5 million kilometers away. The approach was tracked by NASA's Deep Space Network, which is the largest and most sensitive scientific telecommunications system in the world. The final steps on approach included trajectory correction maneuvers and initiation of landing software, which executed automatic commands. Entry, descent, and landing included a combination of technologies inherited from past NASA Mars missions, as well as exciting new technologies. Instead of the familiar airbag landing of the past Mars missions, Mars Science Laboratory used a guided entry and a Skycrane touchdown system to land the 900-kilogram rover. The first tests conducted after safely landing included measurement of Martian temperatures to make sure they don't necessitate restrictions on operations, test communications with Earth using the high-gain antenna, test communications with Earth and orbiting spacecraft using the UHF antenna, unfold the mast carrying the panoramic and navigation cameras and some of the science instruments, take images as soon as possible, help mission controllers pinpoint the rover's precise location based on ground images, orbital images, and the length of time it takes for signals to travel between the rover and orbiting spacecraft. The Curiosity rover is a robot geologist and chemist in one, which can acquire information about the geology, atmosphere, environmental conditions, and, of course, potential biosignatures on Mars. Instruments on the rover include cameras for imaging, spectrometers for chemical analysis, radiation detectors, environmental sensors, and atmospheric sensors. So initially, the primary mission time was to be of 1 Martian year, or 687 Earth days, but we know the rover has been there for over 1,000 Earth days so far. The rover can collect, grind, distribute, and analyze approximately 70 samples of soil and rock. On May 15 this year, an image from the Chemistry and Camera, or ChemCam, instrument on the Curiosity rover showed detailed texture of a rock target called Yellowjacket from Mount Sharp within Gale Crater. This was the first rock target for ChemCam after restored capability for autonomous focusing. Taken just last April from the navigation camera on the Curiosity rover, this image shows the terrain ahead of the rover as it makes its way westward through a valley called Artists Drive within Gale Crater. To wrap up, I've left you with a link on how to get to Mars in 1 minute.